A steel rod of 3 m length is manufactured at 250 C. The temperature of this rod increases to 1250 C. What is the free expansion? Take E equal to 200 GPa equal to 12 into 10, 6 by OC, diameter equal to 12 mm. Option D 3.6 mm. A steel tube E equal to 200 GPa has an internal diameter of 40 mm, thickness 10 mm, and a length of 2 m. If it is subjected to an axial pull of 80 kN, the stress in the tube will be dash MPa 50.13. A steel tube E equal to 200 GPa has an internal diameter of 40 mm, thickness 10 mm, and a length of 2 m. If it is subjected to an axial pull of 80 kN, the change in length of tube will be dash mm 0.5 mm. The axial force in the portion AB of the member shown in figure 1.1 is Kn. Option 50. Option A 50. If the member shown in figure 1.1 has a square cross section of 25 mm, 25 mm and E equal to 200 GPa, the change in length of portion AB is option A 0.24. The axial force in the portion BC of the member shown in figure 1.1 is Kn. Option D minus 40. If the member shown in figure 1.1 has a square cross section of 25 mm, 25 mm and E equal to 200 GPa, the change in length of portion CD is dash mm. Option B 0.16. The axially load composite rod shown in figure 1.2 has a uniform cross-sectional area of 500 mm too. The module of velocity or EST equal to 200 GPa, EAL equal to 70 GPa and ECU equal to 120 GPa. The change in length of CD is mm. Option A 0.15. The axially load a composite rod shown in figure 1.2 has a uniform cross-sectional area of 500 mm too. The module of velocity or EST equal to 200 GPa. EAL equal to 70 GPa and ECU equal to 250 GPa. The change in length of the composite rod is mm. Option B minus 0.95. For the stepped rod shown in figure 1.3, the stress is maximum in steel. For the stepped rod shown in figure 1.3 in option A aluminum. The steel bar ABC E equal to 200 GPa is 1 m long for AB equal to 0.7 m. It has cross section P area of 500 mm too and BC equal to 0.3 m. The cross section area is 400 mm2. The bar is subjected to an axial pull of 200 kN. The stress is maximum in BC. The stepped bar of steel consists of a permotion with cross section area 500 mm2 connected to a portion with cross section area 1002. Each portion has a length of 1 m. The modulus of velocity of steel is 200 GPa. The maximum elongation of the bar by applying an axial tensile force at the ends without exceeding a stress of 100 MPa is option B 0.75. The change in length of a rod of uniform circular cross section was found to be 2 mm for some applied force. The change in length of a rod of the same material and length but half of the diameter subjected to the same force will be option D 4. A strip of steel E equal to 200 GPa 0.25 has a length of 1 m, width of 200 mm and thickness of 10 mm. A line of length 1 m is drawn parallel to its length on one of its side surface. When the strip is subjected to an axial tensile force of 100 kN, the length of the line will be 1000.25. The change in length of a rod of uniform cross section was found to be 2 mm for some applied force. The change in length of a rod, some of the same material and the length but of twice the cross section area subjected to the same force will be dash mm 1 mm. Two rods have uniform cross section areas in the ratio 1:2 and are subjected to axial tensile forces with the magnitude in the ratio 2:1. The stresses induced in the two rods will be in the ratio 4:1. Two rods have uniform cross section areas in the ratio 1:2 and are subjected to axial tensile forces with magnitudes in the ratio 1:2. The stresses induced in the two rods will be in the ratio 1:1. Two rods have uniform cross section areas in the ratio 1:2 and are subjected to an axial tensile forces of the same magnitude. The stresses induced in the two rods will be in the ratio 2:1. If an axial force of 15 kN is applied to a rod of 25 mm diameter, length 300 mm, the change in length of the rod was observed to be 0.045 mm. The modulus of velocity of the material is 200 GPa. The strain in the rod will be 1.5 star 10-4. If an axial force of 1 kN is applied to a rod of 100 mm, cross section area produces change in length of 1 mm over a length of 12 m. The modulus of velocity of the material will be option D 120 GPa. If an axial force of 1 kN is applied to a rod of 100 mm to cross section area length 5 m and the modulus of velocity of the material is 100 GBA, the change in length of the rod will be 0.5 mm. The longitudinal stress developed in a rod of cross section area 500 mm2 is 100 MPa. The force acting along its axis is option D 5.5 kN. If an axial force of 1 kN is applied to a steel rod of 100 mm2 cross section area, the stress in it will be option A 10 MPa. Two equal and opposite forces of magnitude 10 kN are applied at the ends of a steel wire. To increase its length, the internal force in the wire will be dash kN, 10 kN. The value of factor of safety is always greater 1. The value of margin of safety is always equal 0. The radius of wire stretched by a load is doubled, then its modulus of velocity will be unaffected. The factor of safety depends on option D 4. All of the above. Magnitude of external force, properties of material, dimension of the component. The thermal stress is given by where question equal to coefficient of linear expansion, T equal to rise in temperature. Option A E question mark T.